In this video, we're going to look at simplifying an expression that involves various radicals. And so we're going to have to use several properties of radicals to make this look a little bit nicer. Now, if you just look at the problem, you can see it's pretty ugly. We have 2 times the square root of 45 minus 7 times the square root of 180 plus 13 square roots of 98 minus 3 square roots of 2. But the nice thing about this, even though it's kind of crazy and there's a lot going on, is you can break this down step by step, piece by piece, and simplify each term. So what we want to do is we want to use properties that we've talked about before. We want to write the 45, the 180, the 98, and we don't have to worry about the 2. But we want to try to write those first 3 to simplify those radicals, and we want to write them in terms of their factors, one of which is a perfect square. So let's just look at the 2 square roots of 45 first. So we can go ahead and bring down the 2. But we want to do something under that radical. And what we were looking for is we're looking for 2 factors of 45, one of which is a perfect square. So you can use a calculator for this, or you can make you a list, but what we're looking for is 9 times 5. Now 45 is other various things multiplied together, but we're choosing the 9 times 5 because 9 is a perfect square, meaning we can take the square root of that cleanly. So now let's bring down the minus 7, and let's do the same thing we did with the 45 with the 180. So 180 has a lot of different factors, so you may want to make several lists, but the best thing we can do is we can do 36 times 5. Because really you want to look for, if it has several different perfect squares, you want to look for the largest one. It'll just make your life easier. Let's bring the 13 down, and let's do the same thing with the 98. You're looking for factors of 98. The best choice we have is 49 times 2. And then finally, we can just bring down the minus 3 square roots of 2, because we can't break 2 into any factors, one of which is a perfect square. So now let's rewrite this problem using a property of radicals to where we can take multiplication under one radical and break it into multiplication between 2 radicals. So let's write this as 2 square roots of 9 multiplied by square roots of 5 minus 7 square root of 36 multiplied by the square root of 5 plus 13 square roots of 49 times the square root of 2 minus 3 square roots of 2. And so now specifically, the next step is going to be to simplify the square roots that have perfect squares underneath them. In other words, they turn into nice clean numbers. So we bring down our 2. The square root of 9 is 3. And just bring down the square root of 5. We have 7. The square root of 36 is going to be 6 times the square root of 5 plus 13. The square root of 49 is going to give us a 7. Bring down the square root of 2 minus 3 square roots of 2. So now let's do some multiplication. 2 times 3 is going to give us 6 square roots of 5. 7 times 6 is going to give us 42 square roots of 5. 7 times 13 is going to give us 91 square roots of 2 minus 3 square roots of 2. And so now you may think, okay, we've done a lot of work, we're probably done. Well, not quite. There's one other thing we can do. We have some like terms. We have 6 square roots of 5 and 42 square roots of 5. We have 91 square roots of 2 and 3 square roots of 2. So another kind of property, I guess you could say, of radicals is if you have the same radical, that means they're like terms, so we can combine those. So looking at the square roots of 5, we have 6 minus 42. So that's going to give us minus 36 square roots of 5. It's just doing the 6 minus 42. And then for the square roots of 2, we have 91 minus 3. That's going to give us 88 square roots of 2. And that's our final answer. Negative 36 square roots of 5 plus 88 square roots of 2.